All right, welcome back. We are jumping into the next lesson, which is on transversals again, but now we're not just working with any old lines, we're working with parallel lines. So the name of the lesson is going to be transversals and parallel lines. Okay. So right here, it says, give an example of the following. This is the stuff that you learned in 3.1. What is an example of alternate interior angles? Remember, this is your interior. That is your exterior. And then we're talking about whether you're switching sides or switching the side of the transversal or if you're on the same. So alternate interior angles. That would be 3 and 6. And it only asks for one example, so we're only going to do one. The next one, same side interior angles. Interior, same side. How about 6 and what's on the same side but on the interior? 4. Cool. Alternate exterior angles. This is on the exterior, now, what is alternating sides and also on the exterior? That would be over here, angle 8. Angle 1 and angle 8. Remember, we're not going to say 1 and 2, even though they're on the exterior and alternating sides, because those are just a linear pair. Corresponding angles. Let's do this one. Bottom left. What's the bottom left on this one? Bottom left would be angle 3. So we have these type of angles, whether we have a transversal intersecting any old lines or if they're parallel. Today, we're going to be looking at the specific case where these lines are parallel. You end up with special types of angles. So let's go ahead and move on. In the example above, the transversal intersected two parallel lines. That is the most important thing about today's lesson. They're parallel lines. This is a special case, which results in special relationships between the angles. Using a piece of tracing paper, trace one angle and see what the relationship is. Okay. Well, we can't do tracing paper, but let me go ahead and do this. If we had this transversal, let's take a look at the alternate or the corresponding angles. How are they related? Look at this angle right here, and this angle right here. How do they look like they're related? Do they look like they're complementary, supplementary, congruent? They are congruent. So corresponding angles will be congruent. That is one of our theorems. Okay, postulates, one of the two. Next one, alternate interior angles. How about this angle and this angle? Do they look like they're complementary, supplementary, or congruent? Well, if I trace this out in paper and then I rotate it over here, it would sit perfectly on top of it, which means they are congruent as well. Let's look at the next one. Next one says alternate exterior angles. Let's look at this one and this one. Complementary, supplementary, or congruent. If I trace that out and put it up there, it would sit perfectly on top, so it is also going to be congruent. And then the last one, this one's a little different. If I took this angle and I looked at this angle over here, do they look like they're congruent? They are not congruent, but since I know this one is congruent to this one, and these two make a line which is 180 degrees, aka supplementary, then same side interior angles must also be supplementary. These are your theorems. If you were to use these theorems in a proof, you would say corresponding angles theorem. If you don't say theorem, we might think you're just talking about any old corresponding angles. And remember, there are many corresponding angles that are not congruent. It only is when these are parallel lines that they are congruent. That's why you have to say theorem. Alternate interior angles theorem. That's how you say theorem if you want to shorten it, THM. Alternate exterior angles theorem, and so on. All right. So if we look at this and we want to apply the theorem, it's either going to be congruent or supplementary. 3 of them are congruent and 1 of them is supplementary. So this is an alternate exterior angles. Even if you didn't remember and you couldn't look at your notes, look at them. Do they look like they're congruent or supplementary? They look congruent. And if they're congruent, you guys know you can set them equal to one another. Once you have that, you add 4 and add 4, you get 117 equals 3x. And when you divide by 3, you should get an answer of, calculator, 117 divided by 3 is 39. So your answer here is 39. Look at these ones. These are same side interior angles. Are they supplementary or are they congruent? You can visually look at them. Are they congruent? Nope. Then they must be supplementary, which means you can add them and set equal to 180 degrees. So here we have 5x plus 65, because I'm combining these things, equals 180. When I subtract 65 and subtract 65, we end up with 180 minus 65, and we have 115. So 5x equals 115. And when you divide by 5, you end up with 23. So once again, 3 of the different types of angles are congruent, and then same side interior angles are supplementary. Ta-da. Okay, now let's move on to this. So sometimes the angles aren't obviously same side interior angles or corresponding angles or something. What I'd like you guys to do is try to figure out what type of angles these are. Should they be congruent or should they be supplementary? And then solve the problem. Okay, these are corresponding angles, top left, top left. Corresponding angles are congruent, so therefore you can set them equal to one another. Next one, if these are parallel, this is your transversal, and we ignored this stuff right here, what type of angles are these? Same side interior angles. So how do you solve that for x? Go ahead and do it. Well, since they're supplementary, we can say 2x plus 100 equals 180, which is 2x equals 80, and x equals 40. Now, if you wanted to solve for y, you can do the same exact thing. 3y plus 50 equals 180. 3y equals 130. That's your answer for y. So even though these didn't look like SSIA, same side interior angles, if you extended these sides out and made this into a transversal, you would see that you were talking about SSIA. Great. All right. What are we going to do now? We are going to be doing proofs. Okay. Now, what this is doing is this is saying that we can assume, this is giving us some little rules. This says in this proof, go ahead and assume that this is true. Same side interior angles postulate, okay, you're fine. But I want you to prove that alternate interior angles are congruent. And you cannot just say alternate interior angles theorem. For right now, we're using this as basically a practice for doing proofs. So we look at this, I need to come up with a plan. What could my plan be? I'm just going to do some work over here, which is just ugly. We know that 3 plus 6, and once again, this is not correct notation. This is ugly. Don't do this. This is just to think. We know 3 plus 6 is going to equal 180. Why? Because of SSIA. I'm allowed to use that. Is there anything else we know? Do you see any vertical angles or anything? Well, I see 4 and 3 are a linear pair, so therefore 4 plus 3 equals 180. Once again, this is bad notation. This is just us tinkering. Why in the world would we ever want them to both be 180? Well, then I could set them equal to one another. Once I did that, what could you do? Subtract these away, and then you're left with that. Okay, I think we can do this then. Let's go ahead and do the proof. So, given m is parallel to n, given. You have to state that before you can use any of the postulates or theorems. At this point now I can say angle 3 and angle 6 are sup. That's SSIA postulate. We said that we also knew angle 4 and angle 3 were sup. That is because linear pairs are sup. Now I'm going to be lazy and efficient here. We could set both of these equal to 180 and then set them equal to one another and subtract, but I am going to be extra lazy because I have my specialty tool that I'm able to use. What did we learn? If two angles are supplementary to the same angle, then what do we know about those two angles that are sup to the same angle? They must be congruent. So you can go over, that's a specialty tool, angle 6. We can skip all those other steps because we made a different theorem that allows us to skip all the steps because we know that the congruent supplements theorem says two angles supplementary to the same angle must be congruent. If you forgot that, then you would just go the process of setting them both equal to 180 and then setting them equal to one another and solving. But I am going to be lazy and efficient, and I remembered that I have that specialty tool, so I'm going to go over and do it. It's like any other toolbox, like I said. If you had a toolbox and you had a bunch of tools in there, there might be a specialty tool that cuts the hole in the door, okay? If you didn't have that specialty tool, you might need to go over and use other tools, maybe a few tools to do that same exact process. If you remember that you have this specialty tool, cool, then you can use it. Okay. The other way to think about this is we used tools that I already had to build this one. We went through the process of showing that if two angles are supplementary to the same angle, they're congruent. So then I can use that on its own. I could skip the other steps. So hopefully that made sense. Both the way I explained over here, setting equal to 180, then setting them equal to one another, and then subtracting, or just remembering the congruent supplements theorem. So we're able to ignore all these. Otherwise, we would have had to do the whole process. All right. Guess I'll show you, since we have time, I'll show you what the process would have been. Once you got here, I'm going to show you what you would have done. You would have said measure of angle 3 plus measure of angle 6 equals 180 because of definition of sup. It's kind of like the vertical angles theorem proof. Measure of angle 4 plus measure of angle 3 equals 180. Definition of sup again. That just means the same thing. Then you would have said measure of angle 3 plus measure of angle 6 equals measure of angle 4 plus measure of angle 3, substitution. Then you would have had to subtract away the 3's. Measure of angle 6 equals measure of angle 4, subtraction property of equality. Then you would have had to switch the sides. How would you have done that? Symmetric property, and then you would say definition of congruence. But all of these steps can be left out if you just remember that you can use the congruent supplements theorem. All right, I think we have one more page. Okay, let's say you had this. Find angle 7. Well, if angle 7 is 75 degrees, Then what do we have? If angle 7, find 1, 3, and 5. We are only going to do one of these. So if this is 75, try to find out what 1 is. 1 is also going to be 75 because they're alternate exteriors and those are congruent. Figure out what 3 is. Bottom right, corresponding angles are congruent, so that's 75 degrees as well. And 5. Ooh, those are vertical angles, and vertical angles are congruent, so 75 as well. So we can use all the different theorems to be able to figure out different measures of angles. Okay, on this one right here, it says find all the measures. What type of angles are the 105 and the 7? Those are vertical angles. Vertical angles are congruent. So that would be 105 degrees. Bottom right and bottom right are corresponding angles. Corresponding angles are congruent, so it must also be 105. Oh, therefore, if these are vertical angles and this is 105, then this must be 105. Since these are parallel as well, I can do kind of the same thing. These would be alternate interior angles, so that would be 105. These ones are linear pairs. They must add up to be 180, so this has got to be 75. You can see how I'm just using logic to jump around the figure. Oh, now I know this one. These are vertical angles. If that's 75, then that one must be what? 75. Those are same side interior angles. SSIA are supplementary, so what adds to 105 to be 180? 75. And these ones are alternate interior angles. So they must add to be, well, they don't add to be anything, they're congruent. So if that's 105, this is 105 as well. So the whole point of this problem here was to learn that you can jump around the figure and you can be justifying it by alternate interior angles theorem, vertical angles theorem, SSIA postulate. I wouldn't take off if you said theorem instead of postulate. Alternate exterior angles theorem. And what else? Corresponding angles theorem. You can use all of these things to jump around and justify things. We have one last problem. It looks like this was a short lesson. You're building a woodshed. You've already put up both of the walls. One is 6 feet high and the other one's 10 feet high. You then use a metal brace, which is bent at a 130-degree angle, to attach the roof to the smaller wall. You want to create a brace to attach the roof to the back wall. What angle should you brace? Should the brace be at? So here's the ground. Here's the front wall, which is shorter. Here's the back wall. I'm assuming that this person is making these parallel because they're making both of them perpendicular to the ground. They have a little roof that's going to go on there. He finds out that this angle right here should be at 130 degrees. Now he's working over here on his little workbench, and he really does not want to be on a ladder trying to bend this out. So he should be able to figure out exactly what this angle should be, so he can just go up there, and when he is up there, then he just screws it in, and he doesn't have to be bending while it's up there. Well, if these are parallel, and here is kind of like a transversal, what type of angles are these? SSIA. Same side interior angles are what? Supplementary, as long as you have these being parallel, which means they must add to be 180 degrees. Well, if this is 130, then what should he bend this one at before he gets up on the ladder to go over and screw that in? 50 degrees. So he bends it at 50, gets up on his ladder, screws it in. All right, I just want to do a real quick recap on the most important stuff. This is the most important stuff right here. Knowing that corresponding angles, if you have parallel lines, are going to be congruent. Alternate interior angles, if the transversal is cutting at parallel lines, then they're going to be congruent. Alternate exterior angles are congruent, and same side interior angles are sub. You ever forgot that on a test or a quiz? Draw two parallel lines, draw a transversal, and look at it. Whatever you do, don't draw your transversal perpendicular, because then you can't tell if they're congruent or supplementary. It's weird. So make sure you go over and actually draw it like that. Alrighty, I hope that makes sense. Once again, the book says that one's the postulate, and then you can use that to figure out all the rest of these. If you call that a theorem, I'm not going to take off points. Thanks for watching. Bye-bye.